Hello everyone, welcome back to my YouTube channel, and my name's Andy, and I'm here to go over some problem for section 6.4. I know this is kind of like a work, I know this part of math 125 is the most annoying. So I'll just give some like the basic introduction work and how just different solve different problem. I apologize for like this like response because I was being so swamped last week. I have some midterm last week, so I didn't have many time to make some homework videos. I'm now trying to make it up. So I hope this real video just give you some like more material for the final exam or like midterm 2 review. I hope it's helpful, and I'm gonna do my best to provide high quality educational resources to everyone taking math at UW. Thank you so much. Hope you guys appreciate it. I know this is late, but late is better than nothing, right? Okay, let's get started. The first one is like the variable force of a 2x to the power negative 2 pounds movement object. So, along this is the height. Like you want just to calculate the force, just we had to force distance. This is like the force, like what in physics. We want to calculate the force used to pull an object in a certain height or horizontally. In this case, we have a function defined, perfectly defined. We find it, and the distance right here from 1 to 13. So what we should do is we have the distance have the force. You just need to compute. So just this integral from the integral of 2x to the negative 2 from 1 to 13, that is your work. Easy. Number 2, there's no function, but there's going to be like read a graph here. So one and like the distance of 24 meters. You have the graph here from 0 to 24, and the question asking for the work need from 0 to 24. So we need to add basically everything under this. So just the area under the curve, that's your work. When like there's no function presented, there's like just a graph here, just everything under the function. I have a moon discussion. I have a question. I have a review guide from a server wrote in winter, and this question deserves some very special attention. So I will do this in my homework study guide. This is like tutorial. So I've done this because this one's gonna be like the basic kind of entering like the main part of the work problem that you may encounter in Math 125 or Physics 121 if you're taking the course right now. So number 13. You want to just get this work, and then like now you just define, okay, this is gonna be a, and now you just need to find it's like happens to weight like 0.6 pound per feet. 50 feet is just the length, and height number of edge of building 140 feet is high. In this case, it's the only thing you do not need to compute with integrals like the height of a building. Okay, so I'm just like sorry I was texting a messenger because my Instagram was got hacked. Now just gonna restore my account. Now is everything good. So let's back to it. 50 pounds. This is gonna be 0.6 pound per feet. So what we need to find is like the force by the gravity. It is each section of the rope. It's gonna be 0.6 delta x, and we just divide the rope into like different segment, perhaps as x different segment. Each this segment we call them like delta x. And the work done lifting the rope, it can be like 0.6 delta x and x. And it's like find total work done. We need to find the sum section, so it's gonna be Riemann sum. So it's gonna be from 0 to the 50, and it's like it's 0.6 x dx. This is your integral, and just ignore this. This is gonna be the top of the building to the rope, and part B is gonna be worked on pulling half the rope. Half of the rope here, you just need to be careful because they may not be the same. Half a rope, just multiply the half, because like when you just only do the half, the work is halved. So you need to do the height gonna be 20. The distance gonna be 25 feet instead of 50 because we hit half of everything. Okay, number 17. This is gonna be like another tough one. I will introduce how you do this problem. You have 13 meters, a constant speed of a rope that weighed 0.8 kilogram per meters, and the leaky bucket. This is the leaky bucket problem. This is a pretty classic work problem in Math 125 and Physics 121. Initially, the bucket contains 39 kg of water, but the water is kind of leaking out. And finished the drain just as the bucket reached the 13 meters level. So by the time it reaches 30 meters high, there's no water in the bucket. So we lift the end of the rope, but distance perhaps is a y, because it's a vertical distance, so it's like y. For horizontal, we just do them like it's x distance. And with the mass of the rope is remaining from, we call them like Fi subscript and m minus delta m, and like its rho is like the mass is density of the rope times 13 minus y. It's like, and just like your mass remaining on the rope. The density of the rope is gonna be like 0.8 kilogram per meters. And then this is you try to find it's gonna be like the work is gonna be the m, and it's gonna be like a density 0.8 times 13 minus y, then delta y. The total work left with the rope just constructing 13 meters, just the total work sum just write like in kind of like a Riemann limit form. The 10 it is the bucket, so don't be confused. So 13 is the height you want aiming for. And then the integral is gonna be integral of the g is gonna be negative 9.8. Okay, g is gonna be positive this time because it's not it's going to be positive 9.8 because it's not falling down. It's not a acceleration. So be careful. It is positive. The work done cannot be negative. So going to be 0.8 g 13 minus y dy. Then from 0 to 13, that is your work done. Need to be left with a rope. So make sure like your gravity here, it is a positive, not negative, because it's not a acceleration in 5.4. So be careful. This number 23, it is pumping water. This is like another problem worth talking about. So I will send this problem later in like a handwritten study guide or like PDF study guide. But it's the one thing, just you find like kind of volume, just like the work distance is like the pumping. And the following like this one, number 20, this is like a sphere. So I'm just going to discuss this problem instead of it. This is gonna be a hard one, but so I'm just gonna make sure that I'm gonna talk about like more problems. Like this is a chain problem, number 16. So up to number 16, like the chain problem. You have a chain about 10 meters long and the mass is 70 kilogram. How much work is required to trace one end of the chain to a height of 6 meters? Use 9.8 meters per second for g. In this case, it is positive. So the density is like the mass over length going to be 7 kilogram per meter. This is your density, and the mass of we write as like kind of a Riemann form. So the mass is going to be like the density times like delta y, your vertical distances. And to work to the left, it's going to be the density times the gravity here, and then the y, the delta y, then that's going to total work. The Riemann limit is going to be, the limit is n approaches a 0, n over like sigma notation, I equals to 1, then capitalize W, I subscript, and then y, which will asterisk, the asterisk I, they're just going to be, the Riemann integral is going to be, or going to be from 0 to 6, the density, gravity, y, dy. That is your total work needed. Thank you, and that's just going to be this question. I will discuss more about like the pool question, maybe later when combining the midterm review, because this is going to be the must-have question on the midterm and the final. You will expect one work problem on midterm 2 and final exam. And this section gonna be your, I would just say, one of the main concern that you should look at it. And thank you so much for watching my homework video, and I hope it's helpful. And have a wonderful day. Thanks so much for appreciation. Sorry I'm posting this so late. I think that's it.